all matter, everything on the planet that has a mass is made from very tiny particles called atoms. Here's an example of that. This is a picture of carbon atoms in a piece of graphite found in the tip of a pencil. If these atoms were blown up to around 10 million times their normal size, they would look like the bumps on the bottom of an egg carton. Scientists use images like this one to study and learn about materials like graphite all the time. But actually getting an image of atoms is tough, since it's impossible for a normal microscope to zoom in far enough to see them. So, if we can't see them, how do we find them? And where do images like this come from? The answer is that we don't see them at all. We feel them instead. In this video, I'm going to show you how to build a working model of an atomic force microscope, or AFM for short. This is a special microscope that feels the atoms, a lot like me feeling the egg carton bumps here with this pencil, and then makes a picture of them based on that. First, I'll demonstrate how an AFM works. Then, I'll show you how to put it together for yourself. If you want more information on this stuff, like why this measurement is important, the attached paper has that, as well as some alternate building materials that won't be shown in this video. So just for reference, this is what a real setup would look like. Instead of a pencil, real AFMs use what's called a cantilever to find atoms. Our model one is going to recreate this setup as best as we can. This is what the AFM is going to look like when it's all put together. I turned off the lights so that the laser pointer is easier to see for the demonstration. Basically, what's going to happen here is that there's a paperclip on the end of the model AFM, and it's going to hit some random household objects that I set up. When it does, it makes the CD strip bend upward, which then moves the laser pointer higher on the paper. The bigger the object, the higher the laser pointer should go. This is exactly how a real AFM works. It's just that ours is on a much larger scale. With a marker, I'm recording where the laser has been. In a real setup, that data would be given to a computer, which generates that image that you saw earlier. And now that you see how it works and what it's supposed to look like, let's put it together. Okay, everything you need to put together the model AFM and a testing station for it is laid out on the table. You're going to need a laser pointer, a small tub of Play-Doh, a couple CDs, some Legos. I'm using Duplo because it's easier that way since Duplos are larger, but any will work. A few strips of cardboard and sheets of paper. You're going to need some regular tape. If you have it, mounting tape is nice, but it's not necessary. You're going to need a paperclip, a rubber band or a hair tie, a zip tie, scissors, and a pen, pencil, or marker. The first thing that you want to do is put the CDs, however many you have, you're going to want spares, so at least 2, into some hot water for about 10 minutes. This is going to soften them up and will make them easier to work with later on. While the CDs are sitting in the water, I'm going to build a testing station. One part of this, as you can see, is just a cardboard strip, and I'm going to put random household objects on it for testing. For me, those are going to be a plastic coin, got I don't actually know what this is, but I found it, and I'm going to use it. Then we got a key, and then lastly, a big eraser. So these are going to be the things that I'm testing out. If you don't have this nice mounting tape, then regular tape works fine. Your setup's just going to look a little different from mine. The other part of it is a larger backdrop to catch the laser pointer when it's being reflected. Also, as I'm sure you've noticed, I've attached Legos to everything. This is so that everything can click into place together, and it makes testing your AFM a lot easier. Next, you're going to want to modify your laser pointer a bit. So take your zip tie and close it. Get it so that it's almost snug around the laser pointer. Yeah, it's going to be a bit tough to slide on if you do it right. But this way, you can just rotate the zip tie a bit, and the laser pointer will stay on with you without you having to hold the button. It's also helpful to wrap some tape around above the button to hold the zip tie in place. My CDs have been sitting in the hot water for a while, so what I'm going to do is cut one into a narrow strip. The CD is still pretty tough, so this is fairly slow going. It's totally safe, it just takes a little force, but if you don't feel comfortable, you could have a parent do this part if you want. You can make this strip as thick or as thin as you want, but if you go too far either way, it won't work as well when doing the measurement later on. It's alright if some of it comes off or if it's got some cracks in it. You'll see over the course of putting it all together that some chunks of mine have fallen out in the process, but it is good to have a couple spare CDs in case the first try doesn't work out. Once you've got your strip cut, you're going to want to make another cut at the tip of it, just big enough to fit the paperclip. The easiest way to do this is to cut two straight lines out and then bend the plastic in the middle until it breaks off. And you can see on the other end I cut out too big of a strip, so it's okay to use the other side if you don't get it right the first time. And quickly I wanted to show you what it should look like when you're done cutting out the slot. Make sure to make it as thin as possible. Next, we want to attach the paperclip into the slot that we cut out. To start out, you're going to want to bend the paperclip and then slide it in place so that it can stay in there on its own. Once you've got it in there, take your rubber band or hair tie and wrap it around the paperclip to really secure it in there. This is the trickiest part of this whole setup. It might take a while to get this right, and that's okay. Just do it as many times as you need to. Now that we have all the pieces, we can put the AFM together. What this basically is a base made out of Legos, as big or as small as you want. You just have to use tape to fix the CD strip with the paperclip in it onto one end. Make sure that the shiny side is face up. On the other side, you make room for Play-Doh. What the Play-Doh is going to do is it's going to hold the laser pointer with the zip tie on it in place so that it can be pointed at the CD strip without you having to hold it there. And just like that, the AFM is done. And the final step is to tape a piece of paper onto the setup that you're testing with so that you can trace your laser pointer's path as it moves. And with that, you are ready to test your AFM. And now we've come back to the beginning, where if everything goes smoothly, you should end up with a pattern of bumps that looks something like this. Check to see how accurate your AFM was in detecting where the objects were and how tall they were relative to one another. This is exactly the sort of data a real AFM gives. Well, that's the end of the video. I hope you've learned a little bit today, not just about how atomic force microscopes work, but also about what scientists really do when they study a material. Again, if you'd like more information on this topic or additional materials you can try to use, all that is in the attached lesson plan. Thank you.